Okay. Good morning. Thank you very much for coming to the TEAS session in Madrid. And luckily, we have it in the middle of the week in a big, cool room. So we will have a nice session. So first of all, before going to the network, just remember to log into Data Tracker, everybody. Okay, so you can take count of the how many people come here, and also you can also vote uh, when we poll here. So here just the usual reminder of the not well that please take a look, and that you the main thing is that you also always need to agree on the IETF processes and policies. So here also our usual reminder of the conduct guidelines. Here this is a group that also uh, uses to have a lot of discussions. So here just please just extend the courtesy and the respect to everybody, and keep the discussions technical and not personal. And here just contribute to the group. Okay, so here just avoid heating up with personal. So here, again, just log into the data tracker, join the queue, always through the tool. And for those, we have one remote presentation today, so make sure that you have everything off until the moment that you are to speak, and use a headset so we can hear you properly there. Just we have our note taking there, so I guess our secretary Italo will take care of the main note takings. But I mean, all help is appreciated there. So you have also all the material in the data tracker where you can see, and I think also we did not put the wiki. We also have the wiki of the of this where you can also see the status. And here, this is the agenda that we have today. So first, Pavan will guide you through the status of the main working group documents that are not presented today. And then I think Med will come and present Joe, the relation between this new group onions that they are, or possible new group onions that the willingness is that they concentrate the service abstraction, so there will be potentially some of the work that has been done in TEAS, or the maintenance of such work, could potentially be done in onions. Okay, so they will present, and we will have some time for debate whether it is reasonable or whether we prefer some of the work to stay in this. And then we have room for some working group and non-working group documents, so the slice topology, the 5QA to DCP mapping, SVP cryptography authentication, and MTD, which there was a side meeting, I think it was a couple of days ago, there was also a side meeting on the topic. Okay, so just very briefly, because now Pavan will go with the detail. So we have a couple of new RFCs, the framework for the NLP-based enhanced virtual private networks, the young model for the virtual network, and we have also several documents that are in the RFC editor queue. And I guess the ones here we have these three documents that we are considered as a bundle because they are locking a few other documents. Also, we were reminded in last CCAM session by Daniele that we were blocking a few CCAM documents also with this. So here we have this update of the T types, the T young, and the path computation. They all are in a bundle. They are just waiting for the write-up. So we expect that to be completed within the next weeks. The L3D topo is waits for an update, and we have just finalized the adoption of the ACT and POI assurance that we just and that's we need the version from the authors. So liaisons, the first one, the liaison on information modeling and modeling coordination, I think that one that is incoming has already been answered, right? If I'm not mistaken, that's already been taken care of. And we have a second one to 3GPP. This liaison on IETF network slice application in 3GPP, 5G end-to-end network slice. And here, what we are requesting is 3GPP to review the draft and that we can receive the confirmation that the description that we are including there is accurate and there is not a misunderstanding between between IETF and 3GPP. So here for the working group, we're not expecting right now anything to review regarding liaisons. And also, we remind that, I mean, even if it's not really required to disclose IPR in our working group, before any either adoption or we're going to the working group last call, we poll to see which are the IPRs that are around there, and we collect them and list them. Okay, so when we go for this adoption process, I mean, everybody's aware if there is anything right out there. Also, we have here that a GitHub, an official GitHub. So if any of you have a draft that is working group data that is not in TEAS, just please contact us, send us the IDs, and we can incorporate it. Ideally, we would like to have one repository per document, but I mean, there are cases where there are multiple documents around. Maybe there are, especially with the young, that they need to be compiled together and so on. That's reasonable. Okay, so here, and as a reminder that even there we are collecting issues, etc. It is very good, but still the consensus happens on the list. Okay, so please also use the list for discussion. And also reminder that if you are participating in a working group document, please before every meeting at least update the status. So say, okay, what has been changed, what are the open issues, and any plans. So if you present is okay. If not, just send an email. Okay? Or ideally, we would like to have a report during the session, especially if there are open issues that need discussion and need to be solved here. Okay, so I think with this we can proceed to the status of the different working group documents. So let me go back to the control. One second. Yes, control. Click here, 1 second.
Next on the agenda is working group document status. Thanks to our working group secretary, Italo, for collating all the status reports and putting the slide deck together. We have also been maintaining a brief status for each of our working group on the working group wiki. Thanks again to Italo for being on top of that. We have 3 documents in the RFCATS queue. We have one working group document that's on the agenda today. That's the network slice topology Young document. That leaves us with 24 documents. The status of each of those 24 documents is covered in the slide deck. We have 4 documents in what we call post working group last call state. There are 3 of those that need a write-up from the shepherds. The shepherds are working with the authors to make sure that the document is ready for being pushed to the final step. Much thanks to Adrian for sending out a detailed review for the Young T document. The authors are almost ready. I think they need at least one more meeting before they can wrap up the final 5-10% of the comments that need to be addressed. So please do expect to see uh, the write-ups to be complete for these three documents in the coming weeks. There's also another document that's in the post-working group last call state. That's the L3T topo document. It's in an expired state. The chairs will work with Shufeng, who holds the pen on this, and see if we can revive this as quickly as we can and push it through to the final step. As you can see, we also have, I think, eight other expired documents. Most of them are nearing completion, so the authors are urged to uh, revive them first and then push them through the final lap. We also have a couple of ACTN documents that are deemed to be last call ready. That's the ACTN POI applicability document and the PM telemetry autonomics document. Uh, we do have both the ACTN set of documents are also up for debate in the audience discussion. So we will see where that lands and then make a call and on where and when we'll take it to the last call. I'll not be walking through the status of each of every document that's listed in this deck. I will, however, double click on a select few, which we believe needs some attention. And then for the rest of them, please do go through the status reports, reach out to the authors or the chairs on the list, and we will be happy to give any clarifications if needed. So let me jump to slide. What happened? Okay. This is the document that talks about the application of IETF network slicing to end-to-end 5G network slicing. This is the liaison thing that Oscar was talking about earlier. We did send out some text for review to the working group last week, I believe. So please do review it if you get a chance, see if there are any edits that need to be made, any other details to be sought from 3GPP, and we'll be happy to incorporate that. We'll wait till Monday and then reach out to our liaison manager and take it through the liaison process. The next document that we wanted to draw your attention to is on slide 9. This is the NRP Young document. A revision for this was published this week. The scalability consideration section has been enhanced, so please do review that. The plan for this document is to progress it after the other two NRP documents get progressed. There are still some open items on this, so please do review it when you get a chance. This is the document that talks about the realization of network slicing in IP MPLS networks using NRPs. There was a discussion on NRP selectors in the MPLS working group. Adrian, who is the co-chair on the MPLS working group and also serves as a technical advisor to TEAS, he sent out some text to incorporate in this document. The authors did incorporate it, but they haven't pushed it out yet. So expect to see that get resolved soon. Again, the NRP as a topic, we have 3 documents. Those documents are also up for debate in the audience discussion. So if you have any thoughts on that, please do chime in when that discussion happens. The last document that we want to draw your attention to in this deck is the NS models applicability document. There was a revision published for this last month. A section was added to explain the terms and the constructs that are liberally used in the document. A section like this is always welcome, so thanks for doing that. This is again a draft that is up for debate in the audience discussion. So if you have any inputs, please do make them on the list. Those were the documents that we wanted to draw your attention to in this slide deck. Are there any questions? Okay. So before we get to the next slide deck, we we are planning on sending out some text for review for a charter update. So expect to see that. We will have a discussion on the overlap with onions, and then make changes accordingly. So next up, Joe. So we did invite Med and Joe to come and give us an overview of the motivation behind onions and how TEAS can coordinate with them. So we'll hear Joe out and then have a discussion on how to proceed on some of the documents.
Yes, hello, my name is Joe Clark, and I am one with Dhruv Dodi, editor on the would-be or could-be working group called Onions. Was anyone at the side meeting on Onions the other day? Oh, a few hands go up. For those of you who weren't, it was very hard to get in. It was standing room only, and we were in the smallest room. But we did have a very good discussion about that. And for those who aren't clued into what Onions is, it's kind of a humorous name, but the goal of it, if Adrian will permit me to use the word, operationalizing network and service abstractions. Onions, the dual meaning, it deals with layers. We have layers upon layers. We have service models in Yang, network models, device models. A lot of this started because of the recent workshop that IAB ran this past December, the NEMOPS workshop, to gather operators' feedback on why aren't they adopting more data model driven, Yang data model driven solutions. What are the challenges they run into? Onions isn't supposed to solve all of that. However, Onions is trying to make it easier to adopt some of these higher level services authored in Yang, make it easier for those operators to be able to use those services. So that's sort of the wherefore, the high level goal of Onions. So restating it, it is making those service abstractions, those network abstractions easier to use, easier to interoperate, and understand the challenges that operators may have in doing that. The tooling challenges, understand the realization challenges of making these services work. For the purpose of Onions, the idea is these abstractions are trying to take the definition of services, the definition of operations at a network level, and up-level them so that you don't necessarily have to care about the underlying device-level components. But we have to make sure that to deliver the service or to deliver the network, the holistic network function that we want, that those lower-level features do exist. So part of the work in Onions is to do gap analyses and understand where there might need to be work happening to define lower level device specific models. But initially it's about coming up with well-authored, well-tested implementations at these higher levels. The side, oh, that is kind of small. I feel for you. Hopefully you have the Meet Echo tool up. Some of the discussion at the side meeting changed some of this, so we had to get the slides in early. Obviously, the main thing that came out of the side meeting was there was a lot of consternation over this concept of mapping. The idea that we would do Yang to Yang mapping seemed to be a bridge too far. Either it's very complex to do, or this is something that's best left up to vendors to implement in the way they see it. So you see the serve as a focal point for network and service abstraction modeling in the IETF. There is a fourth bullet there, specify approaches for mapping between various abstraction layers to enable seamless translation and integration. That will just be dropped. We are not going to initially focus on that mapping. Well, one thing we are going to focus on, or one thing we think is in the remit of this to-be working group, is the third bullet. We're going to take on the maintenance and work of some of the service and network models that have already been created. Those include things like the layer 3 and layer 2 service models, the layer 2, layer 3 network models, attachment circuits, and so on. We think that that is clear, that we can get enough people, enough interested subject matter expertise in the room to be able to do that. The other thing, or one of the other big things that we discussed at the side meeting and is part of the current draft charter text, is this notion of making Yang-based models easier to consume through APIs. What those APIs are is yet to be determined. We don't necessarily need that done in the charter to say specifically what APIs will look like, but we want to define some APIs around the requirements for the APIs themselves, around what would make operators more, entice them more to use Yang-based services, Yang-based data models. Along with that, and maybe not directly spelled out here, there's this notion of tooling. It came up at the NIMOPS workshop. There is a lack of tooling to make using Yang data models or Yang-based services easy. The IETF really isn't about developing tools. And initially, some of the charter text was, hey, let's build tools. It isn't about that, but it could be about doing a gap analysis, figuring out, hey, tooling is needed here, defining some of the requirements for what the tools will look like, and being very heavily involved in hackathons to create proofs of concept there and to test out the interoperability of some of the service and network models that's coming out of the Onion's work. Finally, I want to call out the coordination. That's why I'm here. In the routing area, in the TEAS working group, we've identified a few working groups that Onions would interact with right off the bat. And some of that interaction might involve, and in fact, in this presentation I'm going to cover, might involve taking some of the work, not dropping the work, but taking some of the work that these other working groups are doing and moving that to Onions where there are more, let's say, again, those subject matter expertise, the eyes to help realize some of this and to help test out and prove out some of that interoperability. Some of the working groups that we've already identified, NMOP, there's already some work happening in NMOP or being proposed to do take on some of the NIMOPS workshop work. So we want to be very in touch with what they're doing, but a lot of the CMAP, the topology work will stay in NMOP. With Ops AWG, my working group, I'm co-chair of that, we've already approved, we've already taken to RFC or will be very close to work around the attachment circuits, the service attachment points, the layer 2 and layer 3 network models. That work will, we would think, transition over to Onions for maintenance. And then future work would not come to Ops AWG, it would go to Onions. Now, we're here in TEAS, so we think, and I've got a chart coming up here, we think there are some in-flight drafts here in TEAS that might benefit better from moving to Onions if Onions charters and becomes a working group. And that's the main point for discussion. Speaking of which, so how do we read this? These are the current drafts. MED initially identified these as potentially either moving of interest, of tangential or more direct interest to Onions, and whether or not they could move or should stay where they're at. And there's one where he didn't have a strong initial opinion. So what you're seeing here, the M and the S in the far right column, not set in any kind of stone or any pre-stone even, but just a initial thought on what work may M move over to Onions or S stay here in TEAS. One of the drafts that is going to be presented today, if I understood the agenda correctly, is the IETF network slice topology Yang data model. That's marked with an M. The reason being, some of the drafts that are marked as M are they're implementing or they're looking at the network slicing service model, and they're either that model or they're augmenting that, and the thought was those types of services would be better worked on in TEAS. This is my last slide, so I think it's probably best to open it up for any conversation, any discussion. I've got some of Med's talking points that I can give an initial thought. And really, it's about what does this working group think in terms of whether or not work should move, maybe additional work should move, additional work should stay, if the Onions working group successfully charters. Looks like we have Karidi in the queue.
Hi, Kiriti Compella, HPE. I still have to remember that. So I'm very interested in L2 SM, L2NM, and the same for L3. We've done some implementations. We do the Yang to, I don't call it Yang to Yang, but either YAML to YAML or XML to XML mappings. So you have a sort of customer-defined, a customer service, which then you map into the network. So I have no problem with that. We have some ideas for enhancements or changes to the L2SM and L2NM. Should that stay right now in Ops AWG or?
Right now, since Onions isn't a working group, it would, assuming it doesn't charter, yes, it would probably come to Ops AWG. Assuming this does charter, one of the milestones that draft milestones we have is a next generation or next revision abyss of the network models and service models. So that would definitely come to Onions.
Okay, and the first thing I should do is join the mailing list.
First thing you should do is?
Join the mailing list.
Yes, join. It is already a mailing list, onions@ietf.org. It's one of the non-working group mailing lists, but yes, please do.
Okay, thank you.
Zafar Ali, Cisco Systems. One question for you. You mentioned about Yang to API, and you mentioned about Open API. Can you describe the scope of those Open API? What is that you plan to cover?
Yeah, so the draft charter text uses the words open space API today. That was probably a poor choice of words on my part because it was confused with the Swagger open API, no space. That came up at the side meeting. People have done conversion of Yang data models to Swagger. I think it was Jan maybe who started talking about this, or Per who started talking about this and did it. You get a lot of endpoints, but it doesn't really give you the same value that it would with working with Yang, because you have to know, oh, first I have to go and set this, or I have to go and post to this endpoint, and then I have to do a put at this endpoint, and you still have to know that. So the thinking was maybe Open API Swagger isn't the right API to choose. Maybe it's something that looks more language centric. I'll use Python as an example, something more Pythonic, where you get classes and you have members, and it feels more like you're within that language. But we felt that may be more to the working group to define. So leave it as just an open API and figure out what it is that operator who wants to do the work and what they feel is the right API to go forward with.
Okay, I'll be very much interested in talking with you offline. Thank you.
Sure.
There's interest. Thank you.
I can't see.
Lou is next.
Lou Berger. Lou Berger, sorry for not being quick in the queue. What is the timeline for Onions?
What is the timeline? We had the side meeting. There were a lot of to-dos that came out of that. It's on Dhruv and I now to adjust the charter text. I hope to be done if I get some time this week. I hope to propose that to the mailing list, the changes this week. If that seems to be consensuousness, we will begin the formal work group chartering shortly after the IETF. We hope to have everything done and a working group formed well before 124.
Interesting. So why no BOF?
I don't know. So I'll give you my timeline. A month or so ago, Med emailed me this idea. He said, "Hey, what do you think of this?" And I thought, "I'm just reviewing it. Okay, I think this sounds like a good thing. This sounds like work that should be done." And then he said, "Okay, thanks." Week or so goes by. "Hey, would you like to be the editor for the charter to this?" I'm like, okay. I like to help the IETF. Sure, let me do that. I don't know why it didn't become a BOF. We did the side meeting. It feels like we want to. It feels like the NEMOPS, I guess, gave some sort of mandate or some sort of impetus to start doing to take action.
Sure. And ADs can run
Yep.
things the way they want. But you just made a comment to Karidi that it's premature to talk about moving things. It seems to me that this discussion is a little premature and we've gotten way ahead of ourselves. And this is a comment to our AD, who was here earlier. There he is. Where I really would like to have some public discussion on this before it's chartered. One of the discussions that's come up is what is the role, and I, by the way, was one of the people that was confused by OpenAPI. What was that really trying to achieve, and does it make sense from other working groups' context? And without a sort of public discussion on it, more than just a sort of it's an IETF mailing list, but it's not a working group mailing list. I think it really needs to have that discussion before being chartered. And I appreciate running fast, but we missed an opportunity at this meeting to have a BOF where you would have gotten community input. And I, for one, didn't have time to. I had a conflict at that time. It was a side meeting, and it sounds like even if I showed up, I wouldn't have been able to get into the room. So. I guess I'm raising a process point here, and it seems like we're premature. All right, thanks.
Yeah, well, let me respond and put your mind to rest. So I've had a conversation with Med, and my response was have a conversation with the TEAS chairs to determine, is this something that seems reasonable? We need to have that conversation with the working group and so on and so forth. What I can tell you from the responsible AD for TEAS is I have not agreed to anything. I certainly haven't agreed to move in any documents anywhere at this point. So I would expect that conversation to happen. It will happen. How it's going to happen, I'm not sure, but at least I can tell you, you're not going to see documents suddenly move from TEAS to another working group. I'm not going to allow that to happen. I haven't agreed to that. That's kind of where we stand.
Great, thank you. That is very helpful. I think there's a lot of good things that Onions might do, but I think and I see Med here, so given the opportunity that this is the first working group that I've been in, there's actually formal discussion on Onions, I'd say process check Onions, do a BOF, please.
Okay.
And I was looking at Med more than Jim on that. Thanks.
Yeah, so thank you, Lou, for, I would say, sharing this. I would say that whether we will go for above or not above, this is something I think that's, I would say, not subjective at all, but at least we have, I would say, the feedback out for many people who are really interested in this work. And since we started this work, we reached out all the work groups who are really maybe impacted by this, including TEAS from May. That means more than 2 months. We said them, for example, that we are starting this. Then there's another mail. Maybe there may be some impact about the work we are doing here. Please be aware of it. If have any issue of this, please come to us and discuss, and you will see how we will converge on something that will be working for all of us. So I think the discussion is really happening. Nothing is frozen so far. Nothing is moved, as really Jim mentioned. So it's really up to receive, I would say, the inputs. If TEAS wants to maintain these documents in their own, that's just fine. We just need to converge on this. And we will see about the next step based on the various feedbacks we received from various working groups. We are having this process not only with TEAS. We already, I would say, sent the same list of impacts to the BASE working group, to CCAMP, the same for INMOP, and the same for OPSA working group. So this is really a multiple area, and we really need to have, I would say, some coordination. And based on what I will be receiving this week, I will decide for the next steps. But please continue commenting and sharing your thoughts on what we are doing here. Thanks.
Luis, can you
Luis.
keep it quick?
Luis from Telefonica. Just to highlight the fact that we have a very interesting precedent on the service abstraction, which is the 5G slicing. And so we dedicated time to understand well what were the requirements from CEPP, from Orange side, and so on and so far. And from that, we derive different work, the NRP, and the proper abstractions for the slicing. My takeaway from the discussion on onions the other day was that we are basically, in short term, being very much IETF-centric, so thinking on the mapping, but not thinking on how others will consume the network. And there was this reference to the cloud services and so. I think if we know about the proper work item or time or dedication for that, we are losing an opportunity. And yeah, just to insist that if we are thinking on service abstractions, let's look what others require from us. Otherwise, we will be late for proposing any kind of solution.
That's good feedback. Yeah, we definitely identify that we need to reach out more broadly than the IETF because we need a reason. Who is going to use these abstractions? Yep.
Yeah, Hao Menzheng from Huawei. Actually, I didn't follow the side meeting, but I've looked into the GitHub and tried to understand what is going to be done in this expected work group. My humble suggestion at this moment would be, before we make the decision on move any specific document, let's try to construct a sample document saying Onions is going to improve the document in this way. For example, the Yang2 API or whatever additional work need to be done. And then it may attract people, the technical contributors saying, okay, I would like to improve my draft in this shape as well. And then we can have more work to do and make clear decision.
Okay, thank you.
Thanks, Joe.
Well, I really took a lot of time. Thank you very much.
Thank you. So, I mean, everything that we do within TEAS is built on abstract building blocks. So there isn't going to be a clear demarcation of where each document ends up. So it will have to be dealt with on a case-by-case basis if and when Onions get started. But we will look to coordinate with.
Hi, everybody. I'm presenting on behalf of co-authors and contributors an update on the IETF network slicing topology data model. The document was adopted in March, and we didn't do too many changes, but we have tried to address in this revision some of the major comments we received during working group adoption. So in the 0.1 version, we updated the consideration about the relationship between this model and the ACT-MBN, which is one of the major issues that has been raised also before working group adoption. And we added guidelines on how to choose between this model and the CTM version 2 and few editorial improvements. We forgot by this update that actually one of the comments was to move some of this consideration from the appendix to the main body. And we did that on Monday. We moved some of the relevant text from the appendix 801 to the new section 2.2. That was the comment. So we forgot that point. So what is the relationship with ACTN VN type 2 is quite complex because ACTN VN type 1 and type 2 are a consistent set of two models where ACTN VN type 1 is providing connectivity intent and ACTN type 2 is enhancing the connectivity intent of VN type 1 with topological constraints and topology as resources allocation. The network slicing service model is doing more or less the same thing as VN type 1, is another way to express connectivity intent. Instead of in terms using T matrix, is using SLO, SLE. And the intention of this model is to complement the network size service model with what was missing, which is topology constraints and topology resource allocation. So the intent here, the issue is not VN type 2. VN type 2 is a reasonable model, is very good model, but it is designed to be integrated with VN type 1. Integrating VN type 2 with NSSM is more complex because they are speaking different languages. So the intent here is to have a solution that fits the same requirements, but is better integrated with the network slice service model for connectivity intent. So the guideline is very simple. If you want to if you are using the network slice service model to express your connectivity intent, and you want to enhance this connectivity intent with topology constraints, this is the model that you have to implement. If instead you are using VN type 1 to express your connectivity intent and you want to enhance your connectivity intent with topology constraints, VN type 2 is the draft, that is the model that you have to use. So the guideline is quite straightforward. And the question is, okay, when I use VN type 1 and when I use the network slicing model is not in our scope. They draft the network slice service model as an appendix where they describe the relationship between VN type 1 and network slicing service model. So the split is on the connectivity intent. Once you decide how do you express your connectivity intent, the decision on how do you enhance your connectivity intent with topology is straightforward. And we move this text to the main body. Another discussion we had on the mailing list was there was a comment from Matt to add some condition, but we didn't find our proposal is not to change, neither with a if feature, not with a when. The reason is that there is no when condition. It's if you have a container, if you don't have any constraints, you simply do not instantiate you don't configure any constraints. It is very clear that for that specific connectivity requirement, you don't have topology constraints. On another requirement, you can instantiate that container and you can put topology constraints. So the when is basically when you instantiate the data node. There is no external when constraint. A feature is too broad, is too coarse because the feature is at the server layer. But you can support this model or you don't support the model. So we think that the Young library has all the information that you need to know whether the server supports this model or does not support this model, or whether the server supports this model only for importing grouping, so not for instantiating data nodes. And once you have this model supported, it's up to the client to decide whether to instantiate or not these data nodes, depending on whether he wants or not to enhance the connectivity intent with topology constraints. And then we notice, for example, in 8345, there are additional, they follow the same approach. They augment the base network model with network topology information without any when or without any feature. So we think we are fine with that. Okay, what are the next steps? Okay, we have to continue addressing the comments that was raised during working group adoption, but at least we can try, we would like to get clarification that these two issues that we have already addressed are okay. The commenter is happy with the resolution. And then we will continue addressing the comments and add some examples to better understand how the model works and add security consideration. And of course, we always welcome additional comments and review. And we have a GitHub area in the TEAS repository if you want to track more in details what the authors are doing. That's all.
Any questions for Italo? Thank you.
Thank you.
Hello, everyone. This is Luis from Telefonica. I will present an update of this draft, which intends to propose a mapping from 5 QIs on the mobile side to the ICPs in the network side. The idea is to enforce the quality of the network slices, the quality of service in the network slices. And I will do on behalf of my co-authors, Ivan and Christoph. So as a reminder, basically the document proposes a possible mapping. This proposal is basically for illustration purposes, so we intend to describe the methodology, but not a specific mapping itself. And the idea is essentially to try to identify how we can group criteria for grouping the different FAQ UIs. The FAQ UIs in CPP are defined according to the nature of the service. So in terms of delay, expected or maximum packet loss, and also the nature, guaranteed bit rate, non-guaranteed bit rate, and so on and so forth. The point here is that there are a huge number of IQIs defined, so there are 50 or 60 or something like that. So the idea, and we basically need to carry all of them through the few queues that we have in the transport network. So somehow we need to find a way of managing them And what we are proposing is basically to group them according to the nature, the criteria that we are defining, the properties basically. So the rationale is that we have in a network, we will be delivering service from different sources, 3GPP, ORAN. In ORAN, we have the front haul, we have the mid haul. 3GPP, we have different kind of slices, mobile broadband, URLC, massive IoT. We have other services like residential services, corporate services, and so on and so far. And all of them are being delivered through the same multi-service network. The next figure tries to illustrate this. So basically, we have just one common infrastructure for delivering all these kind of services. So somehow we propose to do this exercise of grouping so that we simplify the way of handling them and mapping them to the different queues in the network. So going into the changes, we basically introduced three main changes in version 0.3. One was the clarification of this work in relationship to slicing, so it reinforces the message that we try to ensure that the quality of service that is being demanded by the customer is satisfied in the transport network, in the carrier network, basically. Second point was to justify why this work is part of IETF. So we don't intend to do any change in the 3GPP side. We are basically taking as input, let's say, what the traffic from 3GPP side is delivered to the IETF network, and we are basically just simply grouping the traffic in a certain way. Again, this grouping is provided here as illustration purposes. So what we are trying to describe is basically a methodology for doing that. And finally, the last comment received was a reference to L4S. We are not covering L4S, so explicitly said that the L4S is out of scope of this document. So next steps that we are trying to do, and basically a little bit of history. Till now, we have presented in TEAS this document in 119 and 120. We also presented in the TSB-WG last IETF in Bangkok. There have been discussions in both TEAS and TSB-WG mailing list. We received feedbacks. As I said, we addressed the document according to that feedback. We, for this last version, also sent an email to TSB-WG, haven't received further comments. So we think that more or less the document seems to be ready. So as next steps, we would like to see that it would be possibility of maybe sending a liaison through 3GPP. Not sure, it probably is not the moment now. I don't know. I don't know clearly the procedures, to be honest. So not sure if the document should be adopted first or so. But would be great to have a view from 3GPP side if this is consistent with their approach. We did similar work with ORAN. In ORAN, this kind of grouping is already part of one specification for the packet switching transport. So the X-call segments in ORAN, the mid-call and so. We would like to confirm as well if TEAS is the proper home for this work. As said, we presented in TSB-WG, but because the work is related to slicing, we think that this would be the proper home, but this is something to be discussed for sure. And if we confirm that the document is stable, and so probably go to requesting the adoption, maybe for next IETF meeting. And the final thing is to update the affiliation from Christoph that now is HPE. And that's all from my side. Thank you.
Hi, Luis. I have a couple of questions just to clarify. One, the scope of the draft is limited to mapping to DSCP also, or you also include mapping to SLOs, because you said at the beginning that each 5G QI had also some delay constraints, etc., which seem to be not only mapped to a DSCP value in a queue, but also to an SLO. Is also that in scope, or just the DSCP mapping?
Just the DSCP. The rationale for this is to aggregate, let's say, or group per characteristics the different 5QIs as in the illustration, and then basically map to the different queues. So basically, it would be DSCP.
Okay. And the second question is, who do you think is the intended reader of the draft and apply and do this mapping? It would be within IETF, or it would be outside IETF?
I would say it's within IETF, so we need some guidance guidance in terms of methodology, how to proceed with this variety of flows that we need to manage. So our main reader will be IETF, because basically we are not introducing any kind of change in 3GPP. So for the 3GPP, it should be something transparent, basically.
Thank you. So, Adrian.
Hi, Lewis. This is Adrian Farrell. I'm struggling still a little bit with the scope and the purpose of the document. And your answer to Oscar there, you use the word guidance, whereas the text at the moment says illustrative examples. And I'm struggling with, this is definitely useful work, okay? What it does is establish that it is possible to map, but also it says, but anyone can map any way they want. Here are just some ways that can be done, so we know it can be done. Great. Why do we need to go any further than having established that fact? Good, we're done. Why do we need to adopt and become an RFC?
I understand your point. So basically, we think that having a kind of methodology could guide the operators to handle the diversity of flows. So somehow there will be always a way of describing the way in which the different operators handle the traffic internally. So it's more a kind of offering a methodology mechanism for dealing with the other parties, with the party from the mobile side and so. So defining kind of guidance. Common ground for setting up a way of handling the traffic. Going into the particular case of Telefonica, for instance, we have different operations across the world, so this would help us to have a common guidance across all our networks.
So maybe the question is, where is the interoperability?
Interoperability could be could be a target, but thinking on previous attempts, for instance, there was analysis in the past from NGMN, so how the different operators do the mapping. Probably the interoperability would not, I mean, there could be problems on having the same kind of mapping across in each of the operators, but the idea of how groups, let's say, could be common to all of them. So basically, interoperate in terms of semantic of what we expect for each group, rather the particular DSCP marking, the DSCP value. Probably the DSCP value could be different, but the semantic of how to treat the traffic could be common. That could be kind of second step.
What is that?
I actually have two comments. First of all, I would think what this could be like, for example, informational RFC as guidance or reference for our operators. So it's definitely, I think, goes beyond just IETF people. It will be very helpful for other operators abroad, I would say. We've all needed clarifications, like Adrian said, etc.
Thank you. Thank you, Boris.
So when you presented this last time, thing in TEAS, it was IETF 120, I believe. There were some vocal comments made. I think the TSV WG folks had some reservations about it. You said you did present it last time in TSV WG as well. There were also comments ranging from getting inputs from 3GPP, getting inputs from operator community as well. So we don't have an answer yet for you as to what the home needs to be. We'll have some conversations and then decide on what would be a suitable home. Yeah, I mean, at this point, that's what our stance is.
Thank you. We will insist, let's say, on trying to collect more comments from TSV WG so that we can have all the fronts covered. Thank you so much.
Thank you. Next, we have a remote presenter. Joel would be presenting RSVP cryptography.
Thank you. This is Joel Halpern. I'm presenting on behalf of the authors of two documents. The author set is not identical. If you want to know who wrote exactly what, just look at the individual drafts. So the two drafts are the RSVP auth v2 draft and the HMAC SHA-2 draft. The key thing about the auth v2 draft is it defines a revision of the RSVP authentication for key agility. Not key agility, algorithm agility, I'm sorry. And it's very carefully designed to be backwards compatible with the existing RSVP so we don't break things as people roll out new algorithms. Then the HMAC SHA-2 draft uses the algorithm agility to say, here's how you use a authentication algorithm that actually works, because, well, our HMAC MD5 doesn't. So the problem is that as defined, RSVP authentication only supports HMAC MD5. I'm a little embarrassed because I co-chaired the CARP working group many, many years ago, which worked on keying and authentication for routing protocols, and should have noted then that the lack of algorithm agility in RSVP was a problem, and we didn't. Okay, we didn't. So now we're trying finally to fix it. So the focus here is to support algorithm agility, and to do so in a modular fashion. So this draft just deals with how do we get the agility, not what are the specific algorithms. There are a few other changes that reduce the operational risks of introducing this. As I said, the main key was backwards compatibility with implementation and deployment, and to maintain multi-vendor interoperability. There's no point in doing it if the different vendors won't work together. So the integrity object, while it can get expanded in size, the basic structure remains exactly the same so that it is compatible. And we don't change the packet processing logic at all, and we don't change the operational logic. And all of this is captured in this draft Atkinson RSVP Auth v2 by Tony and Ran. So what we did, it's now modularized. The key change structurally is that the authentication data field can't be longer than 16 bytes. It was defined to be exactly 16 bytes. So what we did was take a field that must be 0, or is a reserved 8-bit field, and make it an additional length field. If it's 0, then the authentication data is 16 bytes. If it's longer, in multiple of 8 bytes, it tells you how long. To go with that, we require that anything using the new mechanism must support the integrity handshake. Between that and the security associations, you know whether your neighbor is doing the new thing or the old thing. We did update the discussion of key management. So for example, you can use netconf to configure the keys if you want to. It originally talked all about Kerberos. Well, Kerberos was very interesting at the time. Very few people are using it now. And we then had to create an IANA registry for the actual cryptographic transforms. This draft simply creates the empty registry with, well, I think it includes a code point for the HMAC MD5, even though we'd frankly rather deprecate that because it's so broken. Before I go on, I will say, feel free to put yourself on the queue and ask questions. I'd love to answer questions as soon as they come up. The second draft then uses the first one. This one is by Ran and me to actually define how to use HMAC SHA-2, which is a competent authentication algorithm. It uses NIST SHA-2 in HMAC mode. It's a very short document. It uses the standard ways of describing, the common ways. It's not a standard, but the common ways of describing these things. The one interesting bit, there is required to be a value called APAD that seeds things. We picked a random APAD value. The point was to make it different from the APADs used by other protocols, because that's the IETF convention. If somebody thinks there's a reason to use a different APAD, we're happy to change it, but we picked one that just was different from all the other ones. And of course, it adds the use of HMAC SHA-2 to the cryptographic registry. It actually adds 3 entries because SHA-2 has a 256, a 384, and a 512 strength form. So we'd like comments. Sorry. Please read the document. We'd love comments. We'll wait a little while, but we're going to ask for working group adoption in the near future. If we start seeing comments, we'll wait and deal with the comments first, because we'd love to deal with comments. But if there are no comments, we'll just ask for adoption, because this is just a pain. If operators are using RSVP or RSVP TE, and this applies equally to both base RSVP and RSVP TE, then they have no security in practice, because HMAC MD5 is just too easy to break. So we'll ask for adoption, and then we'll hope to have some more discussion and address more comments, and then move to working group approval and then publication. But obviously that goes through the processes, and we'll work with the chairs. But the real goal is this first point: review and comment, please. We'd like to hear from folks. I have backup slides, but I don't see any reason to go through them. Any comments or questions?
Thanks, Joel. When Tony presented the document, I think it was IETF 121, we did a poll then for interest, and based on that, we had added that first document at least to our adoption queue. We should see an adoption poll for that thing in the next few weeks.
Great.
This second document is, we are looking at it as a companion document, so it should go, it makes sense for it to be progressed along with it. When in IETF 121, there were suggestions to keep TSVWG and SAG group as well in the loop as these progress, so we will look to do that. I don't see anybody else come to the mic here, so I think we're good.
Okay, thank you.
Thanks, Joel. Joel, we have a question for you. Sorry.
It's not a question. Hi, Kiriti Kampala, HPE. Thank you for doing this. Bye.
You're the next presenter, Kiriti.
You want to take the question for this one, or not needed?
Hey, folks. Does this work?
It works.
Now he's in control.
Okay, cool.
You have 28 minutes.
All right, I'll try not to use all of them. So hi, everyone. This is an update on the multipath traffic engineering document that I brought to TEAS last time. This time we have a few more documents. So I will do a quick recap of the main features of multipath TE, and then talk a little bit about the other documents. Some of them are in this working group, but some are in other working groups. So I'll focus on what's relevant to this one. Let's see if this works. Yeah, so the basic idea is that you combine the ideas of multipathing with TE. In classical TE, RFC 3209, you have the notion of a path, and this is sort of everywhere, LSP and so on. So you have a path, that means you have one ingress, one egress, and then you have the notion of a path that satisfies certain traffic engineering constraints. So you can do this, of course, with RSVP-TE. You can do it with adjacency SIDs in a SID stack. So that's sort of in our heads. You have traffic engineering equals single path. If you do LDP or node SIDs, you typically get multipathing. There seems to be this dichotomy, but actually, I think we don't really have a dichotomy. We can do both. So what we're talking about here is combining the two features, and what you end up with is an, I'm going to say LSD, a label switch DAG, a directed acyclic graph that allows you to get from your ingress to your egress. So am I in the queue still? I'll get off the queue later. Okay, so I probably have to ask myself questions at this point. Thank you. Yeah, thanks. So you can have So you can have full TE capabilities and full multipath capabilities. So in particular, in the graph above, you see a DAG that goes from 1 to 8. And you can use all the links if you don't put any constraints. But if you put a constraint saying don't use black links, then you end up with something like the DAG below, where the heavy links are not used. So in particular, node 5 also would not, or node 6 would not be part of the DAG. So this is just the colors bit. You can do SRLGs and stuff. But the interesting part is when you get to bandwidth control. So in the DAG on top, you have a request for 200 gig from 1 to 8. And you can just go ahead and equally load balance them. But if you, every link can do 100 gigs, so you have no problem load balancing this. At the moment, you have no other reservations. But if you look at the DAG, the graph below, the link from 5 to 8 only has 10 gig. So you'd end up saying, I can accommodate your 200 gig, but node 1 can actually send 100 gig to each of its next hops, 2 and 3. But node 2 can only send 5 gig because at the end, node 5 can only accommodate 10 gig. So node 2 can send 5 gig, node 4 can send 5 gig, and node 5 will end up with 10 gig coming in and reserve 10 gig on the way to node 8. So the idea that you actually do a computation and you look end to end at the available bandwidth and you actually see that. And based on that, you can then say, this is how I'm going to distribute traffic. So in particular, at node 4 in graph A, you have an equal balancing between the 3 outgoing links that it has. But in node 4 in the lower graph, you have 5 gig going to node 5, you have 90 gig going to node 6, and you have 50 gig. I'm sure the math is all wrong here, but whatever. So you don't have to have equal cost load balancing or equal weighted load balancing. And to do that, you'd look at the whole graph. So you wouldn't look at just your immediate next hops. If you were doing ECMP or multipathing with LDP or just plain IP, at node 4, you'd say, I have 3 outgoing links, so whatever bandwidth comes in, I'm going to load balance them equally. When you do an end-to-end computation, you can say, I can do better than that. So in this case, you'd say, because node 5, the link between node 5 and node 8 only has 10 gig available, I have to do something different than what I would do above. The other thing I want to emphasize is the fact that now that you're not talking about paths anymore, but you're talking about DAGs, directed acyclic graphs, you don't have to have a single ingress or a single egress. So there are many cases where multiple ingresses or multiple egresses make a lot of sense. So for example, in this case, you could have these 2 nodes, which are triangles, which are outside of your network. It could be a CE device in a VPN or a customer device just for IP traffic. It could be peering nodes that you're peering with. And if you say that traffic can come, we're looking at a DAG going left to right. So if you say that traffic can come in from this blue device into node 1 or node 0, because they're equivalent, the device can choose how it sends the traffic, and it can be dropped off from node 9 or node 8 to the blue device on the right. Today, if you wanted to do that with traffic engineering, you'd set up 2 or maybe 4 paths, 0 to 9, 0 to 8, 1 to 9, 1 to 8. Here, you can have a single DAG that says, I'm going to handle all the traffic for these blue nodes. And based on that, you'd have 2 ingresses and 2 egresses. The nice thing about this is the relative increase of state in the network, because you added an extra node 0, an extra ingress, and an extra egress, is quite small. So node 2, for example, would say I have 2 incoming labels, one from 0. I mean, I'm talking MPLS, but you could do other things. it would say I have a label coming in from node 0 and a label coming from node 1. The next hop is the same, which is a multi-next hop that goes to 4 and 5. And node 5 would say, I changed my multi-next hop to include another next hop to 9. And node 6 would do the same. So those are the things that would primarily change. Node 4, for example, would have no change in control plane or data plane state. When I talk about this, and I should thank everyone who came to the side meeting as well as the hackathon. We did a little bit of a hackathon, mostly just discussing things around this. So people ask the question, how is this different from a feature that we have, I think most vendors have, which is, we'll call it here multipath TE containers. So you have two or multiple LSPs from the same ingress to the same egress with very similar constraints. And essentially you load balance at the ingress and say you can take either of the tunnels to get to the egress. If you do that, you get a little bit of load balancing, but you only get load balancing at the ingress. People ask, what are the differences? The main difference is that you have, instead of multiple tunnels, you have a DAG, a directed acyclic graph here. We think there's a lot less state. I'll talk about that in the next slide. Again, when you do this, you don't have load balancing. If you do the container, you don't have load balancing except at the ingress. So every other node will just say, this is the label coming in, this is the label going out. If you want to explore all possible paths, in this case, you'd have 30 LSPs from 1 to 14. Instead, we'd have a single DAG if you did MPTE. The other thing is that at the ingress, while you could do something different, we typically do equal cost, equal weighted balancing across the container tunnels, whereas in a MPTE, you could do an unequal weighted load balancing. So here's a comparison of the states. If you had MP-TED, a DAG with MPTE, you'd have a single tunnel or DAG. If you did containers and you want to explore all paths, you'd have 30 tunnels. So the total number of messages you need to set this up would be 46 for a DAG and 360 for a set of container with a set of LSPs. If you look specifically at R4, you'd have one junction state block, the analog of path state block or reservation state block. So you'd have one JSB with 2 P hops and 3 N hops, whereas in containers you'd have a bunch of PSBs and RSBs. In the data plane, you'd have 3 labels pointing to one multi-next hop for a DAG. If you had containers, you'd have 30 labels coming in, 30 labels going out, and 30 next hops. Again, we talked about having more than one ingress and more than one egress, which you can do with MP-TED, but with containers, you can only have one ingress and one egress. This is a big thing, and I'll touch on this a little bit. When you update DAGs, we think that in most cases you can do the updates in place. When you update an LSP, an RSVT LSP classical one, you often have to do make before break, which leads to a lot of churn in the network. So one of the focuses of MPTE is reducing state in the network and reducing churn in the network. The data plane that we use, we talk about using signaled MPLS, static MPLS, where you have either the same label for incoming and outgoing at a node, or maybe the same label across the whole DAG, which is maybe a little more difficult. And then we talk about multiple types of IP tunnels. One of the companion documents written by Andrew Stone of Nokia is to talk about MPTE in the context of segment routing or Spring. So we should probably add Spring as a data plane to this. In the current draft, we don't talk about Spring. The other thing is that we have a very quick overview of how to install fib entries, given that you have completed your signaling, but I'm sure that can use more details. Okay. Also, in the 0.0 version of the document, we suggested using TCP because, RSVP soft state is killing us. It's not. And I thank you for this working group and other folks and implementers. We've dramatically improved RSVP scaling. So we're going back to RSVP TE. We have, of course, new message types and stuff, but the procedures will be RSVP TE. So you can use RSVP TE to provision this. You can use PCE to provision this. And then there's a data model, so you can use your favorite, whatever APIs you want to use to provision this backed up by a data model. There is some background work on using BGP for this, and so potentially a new AFI-SAFI. That implementation or prototype implementation is being worked on. At some point, we can come back and compare things, but I'm quite happy with RSVP-TE. Okay, so that leads me to RSVP-TE signaling for this. When we wrote 3209, we didn't have PCE. We didn't think very much about how tunnels are signaled and configured, signaled, and installed. But now that we've had, for example, PCE to work with, you can break up the tunnel creation and instantiation into multiple steps. The big one, the main ones are you have a tunnel originator that has the configuration and is responsible for maintaining tunnel state. You have some entity that does the computation, typically a style of CSPF, a constrained shortest path first. And then you have the signaling, and then when the signaling is complete, you say, okay, my tunnel is ready for service. So these functions can be done by different entities or logically, but it could be physically the same entity. The sort of different permutations, not all of them, but some of them are mentioned here. Pawan will probably talk more about this when he talks about this in the context of the PCE working group. So here's a big thing. If you want to, if you were asleep, I don't blame you, but if you please wake up right now, listen to this slide. In RSVP-TE, we're going to have a new message type called MPath, MPTE path message, and a new message type for MPTE RESVs, and then we're going to use notifies. So you can break up the signaling into the signaling source to junction, with junction being all the nodes in the DAG, junction to junction, and junction to downstream junction, or junction to upstream junction, and then junction to source. So the big difference here is you're not sending a path message with an ERO from ingress hop by hop through the network to the egress, because it's very hard to describe a DAG in a simple message. I know you guys had interesting, fun times doing point-to-multipoint and 3 EROs, and then you ended up saying, I'll just do multiple sub-LSPs and enumerate all of those. Well, here you have a combinatorial problem that maybe that's not the best way of doing it. So we decided to just break with the tradition and say, ingress is going to send, or signaling source, but typically ingress is going to send a junction message to every node. It could be 10 hops away, it doesn't matter. And that junction message will tell the junction, you have so many P hops and so many N hops, and this is the load balancing ratios across the N hops. Because you don't have you do have the RESVs coming back in ordered fashion, because it's really nice to have ordered control. But you still want the ingress to know what happened with the path message, so we use notifies freely. And there are 2 types of notifies. There's a notify specifically for this DAG saying, yeah, I managed to set up what needed to be set up. And there's a resource notify, typically used when the DAG is broken or a link goes down or something happens. So those are the junction to source messages. Here's a DAG, and you have the signaling source, which is the ingress, which is R1. And then you have beautiful fonting here, but never mind. So you have a number of other nodes in the DAG, and the egress is R8. And essentially, you're going to signal from R1 to R2, R1 to R3, R1 to R4. So you're going to send a direct path message, MPath message, from the source, from the ingress to each of the nodes. The residues will come back in ordered sequence. So a little bit of an eye chart, but essentially what I just said, the ingress is going to send path messages to every node saying, here's your P hops, here's your N hops. And here's the load balancing ratios for your N hops. The residues are going to come back in ordered fashion. At the same time, when you get the residues and program your forwarding state, you send a notify to the head end, to the ingress saying, I'm done, and my junction is ready. And when everything comes to when the ingress gets all the notifiers and the residues that it expects from its next hops, it says, okay, the tunnel, the DAG is ready for operation. There's an example here of an update sequence. There are several more. I'm not going to go through this in detail. The important thing to note here is we have this notion of in-place updates. So in this case, what we're doing is you're doing a bandwidth change, and typically that happens when you have a feature called auto bandwidth, where you say, measure the traffic going into the DAG, and based on that, update reservations, so that you want your reservations, which is a control plane entity, to closely hew to your actual data plane traffic. So in this case, you're changing the overall DAG bandwidth from 6 gig, which is crossed out in red, to 12 gig. And so you have to basically tell every node, your reservations have changed, and potentially your load balancing ratios have changed. In this case, I don't believe that's the case, but we have many more such sequences. The idea, again, is to reduce the churn in the network, so people who burst into tears whenever they say RSVPTE can stop doing that. So we have less state and we have less churn in the network. So there are many more sequences in additional materials that I've pointed to in the final slide. So we're looking at all these sequences. If you update a DAG, one thing I should have said here is no change in DAG shape. That's a really important concept for us. So the DAG shape is the nodes that are in the DAG and the next hops and the P hops that every node has. So if there's no change in the DAG shape, you don't need to do anything. But if you, for example, in this case, the link from 2 to 5 were to go down for any reason, maybe the IGP says it's down, maybe it's actually taken down for maintenance. Here's a funky thing. Again, if you want to pay attention, we will leave that link in the DAG. We might leave it for a little while. We might say, okay, after an hour, after a day, take it away. But for now, we will leave it in the DAG. So when it comes back up, you're not actually churning things too much. You don't have to send another label from 5 to 2 saying, oh, I had withdrawn my label, but I'm bringing it back. We think that's a nice thing until we actually do an implementation, which is underway. We won't actually understand whether this is good or not, but we think that's a nice thing to do. So in many cases, you will either leave something in the DAG or you will just change the load balancing ratios. So the DAG shape will not change unless you really need to change it. For example, if the link from 2 to 5 has a certain color and you change the constraints on the DAG to avoid that color, then it would be permanently removed from the DAG. Okay, there's a Yang model for this that builds on an existing Yang model. So it has this idea of MPTE tunnel, and it has, so we have these identifiers for an MPTE tunnel. We have versioning for the MPT tunnel. We're revising versioning as we go. So we're trying to have a simple way of understanding what version the entire DAG is at, but we do want to have sort of point changes. So if you look at the additional sequences, you'll see some of that. So the model captures all of that, and then for each junction, it'll say, here are your P hops, here are your next hops, and here's your ratio, which I don't see, but it's there somewhere, or it should be there somewhere. So that's pretty much it. The next steps are to continue adding to both the architecture document, the RSVP document, and the model, all of which live here. And then there's a PCE document that tells you how to initiate an MPT DAG from a central controller, or you can have the delegation mode where the tunnel originator tells the PC, just do the computation for me and give me a list of junctions and I'll go signal them. In RSVP, we probably have to add some more update sequences. The big thing that we want to do is make sure that graceful restart works well. In the Yang model, we probably need more operational state as we understand what we need to do. We will add that. Please send feedback on all of the above documents, unless you're Lou, in which case you can send feedback right now.
Hi, Lou Berger. Have you thought about using this for protection as opposed to just load balancing?
Yes, very much so. So one of the things that I'm working on is computation, which was my job 28 years ago when we did TE for Juniper. So one of the things I want to do is say, look, I have 3 next hops. One of them goes down. I can still keep going. I'll just change the balance across those. I do want to take into account SRLGs as well. And so maybe all 3 next hops are the same SRLG, in which case I do need protection. So there are cases where I have a single next hop and I will need protection if I don't, if I have multiple next hops and there are different SRLGs, or I don't know SRLGs, I might say I don't need protection. So yes, very good point, and we will expand on that in a subsequent release version.
I think you were talking about load distribution plus protection. I think you actually covered that earlier. I'm talking about just protection.
Just protection.
Just protection.
Okay, explain.
At each junction in the DAG, when you go to send, you choose one output.
Yes. I mean,
the problem is when is the failure is multiple junctions away.
Yeah. Okay.
You might make the wrong choice.
Okay. Yeah. I've thought a little bit about that. It's something to, especially when you have a sequence that is single hops all the way to that point. Yes. So again, one of the things is to use a notify, but most notifies right now are junction to source, but we might have a notify from junction to, let me get to a diagram and maybe we can talk.
To prior junction. Or upstream junction.
It's actually there in the set of messages. If you go back to the slide with the
this one.
Go back.
Go back. The set of messages. Sorry. Yeah, got it.
So in the there is a junction to junction message when, say, you have a sequence of junctions where you only have one next stop.
So for example, from 8, you go back to 6, you go back to 4. So if the link between 6 and 8 breaks, go ahead.
Yeah, so in this particular scenario, if the link between 6 and 8 goes, R4 would need to be told that the junction is down. Otherwise, it will keep sending traffic to the R6 next stop. So when the entire junction goes down, there is a junction-to-junction notification that's sent to the immediate upstream junction, which would immediately invalidate the next stop.
And presumably it works for any number of links. It's just the last link.
Right. Yeah.
Okay. Yeah, that would definitely cover it. I think that particular use case is very applicable to what was written up in the raw architecture, which is just now finalizing the RFC publication process approval process, excuse me, at a DetNet. And you'll notice that there's language in there talking about DAGs and protection and making decisions at each, it's not called the junction there, but this aligns really well if you allow for that use case.
Okay.
So that's actually great to see. I think there'll be interest in that in DetNet for using this mechanism. I also appreciate you brought up the notifies, because that brings up a second point, is have you thought about not notifying for all egresses or all paths just to reduce the number of messaging?
So we went back and forth on that. We ended up saying, let's send notifies so that the head end has a better picture of everything. The amount of states right now and the amount of messaging is pretty low, but the notifiers themselves almost double it. So it is something to think about. Again, I think implementation will guide us. But we have several ideas. One is to do it periodically. So instead of saying, okay, I just got my, like for node 4 here, I got my 3 resvs. I sent my 2 resvs to my upstream. I've programmed my thing. Tell the ingress right away. You could say, tell him at some point.
I didn't hear the last thing you said, but
tell
I
him
sort of
at
get what
some
you're
point.
getting.
Yeah.
There's lots of opportunity here for reducing or notify optimization. And you certainly want to hear the first one where you have a full end-to-end path.
Yes.
But after that, it sort of gets less clear.
Right.
Okay.
Understood. And one thing I should have mentioned is that now that you have not a path but a DAG, it's no longer binary up or down. So there's a notion of a degraded thing where maybe everything comes up, but the link between 6 and 8 didn't come up. You say, yeah, I maybe I don't have full capacity, but I do have a functioning DAG.
Yeah, I definitely have to go read the documents and understand the whole bandwidth management thing. I don't understand how this works without a lot of overbooking.
Okay, so as we are a little bit over time, just one comment and we close the.
Okay.
And we close. If you want, Adrian, just make the last comment and we close. Okay. Then I think we close the session for today. I think we encourage to keep discussing and.
So please do take your comments to this. Thank you. And see you all in Montreal.
Yeah. Thank you. Was there a comment? Or?
No, there were, but
you
ran out of time.
Yeah.
So.
Okay. Yeah,